much indeed, Willie. As before, we'll group all the questions just before the next break. I'm going to introduce you now to Kevin Geoghan from Intel Ireland, energy engineer, and he's first up for Intel. One of his colleagues, Joseph Sullivan, will join him shortly. And thank you. And Kevin has worked at Intel in terms of energy conservation projects 2011 to 2014. Intel itself spent over 100 million on resource efficiency and over 1,600 individual projects. Over to you, Kevin.
Good morning. So I'm Kevin Geoghan. I work on the Leakslip site. I'm essentially the energy manager or site engineer on Leakslip, and I also support the corporation from an energy perspective. Okay. And following me will be Joe, who owns the global program for energy conservation. So we split the presentation into two. I'll cover the Ireland stuff, and then Joe will follow with the corporate picture. So for those who don't know Intel, we manufacture computer networking products, over 55 billion annual revenues, over 107,000 people worldwide, and one of the 12 most valuable brands in the world. So I'll just give you an idea of the Leakslip site. So it started off as a stud farm back in 1989, and $12.5 billion later, and on the 360 acres, we've got 4,500 people. Essentially, there's three factories, major factories on the site, which make semiconductor wafers that go into chips for computers, networking products, and so on. More recently, we've developed a new Quark chip, which is for the Internet of Things technologies, and that was designed and developed in Ireland, and actually has on the boards, made in Ireland on the board. So it's a good win for the site in recent years. So for what we're here today for ISO 50000. So energy program goes way back on the site. We're one of the founding members of the with the SEI energy agreements that Magella referred to. And we were one of the first sites to implement ISO 50000. And where that came from is going back to the LAN program. We've had involvement then. We started to get formalized around 2001 on the site with dedicated resources. And then as we got involved in the SEI energy agreements program, and what was really good for those companies that were on that journey at the time was actually the participation, the sharing of knowledge, and you can't underestimate the value of that, of people talking and understanding and getting the knowledge of what works best. And there was a learning program there from the point of view of what's best practices at the time, and what that led into the IS 393 energy management standard. And then we followed on when we got converted to EN 16000. And then in 2011 we got certified to ISO 50000. Since then we've had a number of sites, Costa Rica, Chengdu and Vietnam, and we've other sites following that have got certified to ISO 50000, which I suppose from an Ireland perspective goes back to the original work that we did here, and our process actually got used for those other sites. Our approach to energy management, I suppose that from a 50,000 perspective, was we were already certified to 14,000 on the site, and we used that as a template. And use what procedures were there, use what common policies and so on, and also use it as to support the IPCL license that we have on site and a UETS. So any of those other programs in the Energy Audit Directive. So what from a site perspective, or use what minimize the workload. If you're already doing things for other certifications or compliance, just use the benefit of actually that information to demonstrate the compliance, and rather than duplicating additional activities and procedures. Over recent years, we've invested over 20 million on site in energy conservation projects specifically. We have a cross-discipline approach in that we actually managed across different facilities divisions right through the factory, and very much data driven as regards showing the business value of the projects, and from the point of view of consumption tracking, forecasting, and right up to budget management, it goes right across the board. So from the point of view of partnership with our finance groups, facilities, factory and so on. More recently, in recent years, we're involved in Energy Research Centre I2E2 and the ICMR, which actually now have a standalone entity with their own offices and so on. I suppose the key thing is people in all of this, and from an energy perspective, I think it's worth trying to identify those 20% of people in your organisation that affect 80% of the consumption. And particularly for a large site like us, it's with over 4,000 people, we're not going to get around all of those people. So from a perspective of where the consumption lies, understand who the actual energy users, and you can use the same methodology across any of your offices, sites, or whatever. And for that, you can actually use an approach where you can prioritise between who uses the energy, who can actually change the consumption of the energy, and who can influence it. And it's not necessarily that you may be dealing with somebody who's a technician on the floor. They may have no actual control or power to do anything about the energy use, and trying to understand what the linkages between people and who are the important people to actually engage with, who are the important people to influence in order to actually affect the actual change in energy use. And it's over time that you develop those relationships so that you can demonstrate the actual action and benefits around change in energy use. Some of those organisations may be external companies you bring in for maintenance or whatever, particularly on your high energy users. So if you look at the 50,000 approach, you're going after your significant energy users, align that with the significant energy people, and then determine what the specific communication that you need to have to influence those people. What I'd like to do is actually just talk through a few examples now of projects and opportunities, just to stimulate a bit of thought around how and give you some examples of what we've done so that you can take something from it. So from our site, one of the biggest uses is chill water. We've essentially got clean rooms. They actually we have to control the environment in those clean rooms. We have large chill water systems, that closed loop systems that essentially water cooled. We have chillers, pumping, cooling towers. To understand how they operate, and we've a large range of age of equipment as well. So going back to 1990s right through, so different periods in time when equipment has been installed, and so over the time, a lot of changes on the plant. So typical easy wins that you can actually go look at is chill water, condenser water temperature reset. So you may need to go back and look at your chill water plant, see that you can communicate or change set points remotely, upgrade your BMS system or add additional code, or if you have a standalone chiller vendor panel, they can actually meet those requirements. You may have to put in external weather or temperature to actually do that temperature reset. Look at chiller primers, chiller sequencing in order to reduce the amount of, where you've got multiple chillers. A lot of times plants are left in a situation where the excess chillers operate, particularly during winter time of the year, so you have excess capacity versus minimum demand. So understanding the differences there to reduce that extra capacity in the system for those times. Another key area to look at is excess flow. So see how those chillers are operating, see if there's actually been driven by flow rather than energy or heat load reduction demand, and see if you can influence that flow reduction in the plant. So there are new improved energy valves on the market now. Look at ways of actually identifying those parasitic flows in the system, reduce them in some way. If you have fixed speed pumps and so on, look to go to pressure control on the pumping systems to actually reduce that flow in the system. So these are the types of projects that we've currently done in the past or continue to do across the actual site. Sorry, this is your typical water cooled system. When you actually look at that, then from a climate perspective, Ireland is a key advantage from the point of view of we've a reasonably mild climate, so optimising the use of outside air so using airside economizers or trying to reduce that load is pretty important, associated with actually improving your chill water plant efficiency. One of the key pieces then is where you can go to use our climate more is actually using wet side economizers. So trying to cool the return flow back to your chillers in some way. We've done this. We did it on a data centre here in Ireland, in Lake Slip previously, where we actually dedicated a tower to actually reduce the chill water going back to the chillers, and they allowed the chillers to turn off for that period of time, particularly during the winter. You can also do it in buildings and so on. You can also use dry coolers if you don't have cooling towers to actually affect that actual reduction in return chill water demand. One of the key areas of investment which we've done over the years is heat recovery, and this is where we use chillers to provide the heating for the clean room. So all of our major clean rooms now, we don't use boilers or natural gas to actually heat the clean rooms. We use heat recovery chillers. They're essentially a heat pump that provide two functions, both cooling and heating. So what it means is for the actual facility itself, that your air handling units and so on have to be able to use low temperature hot water. So we're talking about 40 degrees Celsius running through the system, and therefore you get the benefit from the point of view of doing your cooling and actually your heating. And one of the key things is actually with those heat recovery machines, they actually do run on a higher COP, but that actual higher COP as regards the increased electricity use is minimal compared to the energy used to actually provide heating for boilers. So all of our newer factories, and we're doing the last of the major clean rooms this year to actually change over to this. So we've done since from 2002 was our first plant. So across we've a large over 20 megawatts of this heating the clean rooms. I suppose one of the key considerations is whether you use heat recovery or heat pumps. One of the difficulties with heat recovery chillers is having to control the machines to serve two functions. So it may actually be much better to actually look at heat pumps and do it in a similar way to discuss with regard to the wet side economizer, where you cool or take the heat out of the return chilled water in the same fashion. These diagrams are from Intel white papers that they're available on the web. There's other discussions associated with data centers. I just use them for example. And I think it's a good way to look for the opportunity to use that waste heat that's in the system that we have to cooling anyway. So I'll hand you over to my colleague Geoghan. Okay.
Hi, my name is Joe Sullivan. I manage the energy conservation program for Intel globally. So we have a counterpart of Kevin's at each of the major Intel sites. So we have 16 people in total dedicated full-time to energy efficiency and energy conservation across the Intel operations. So just to give you a feel for the scope, Intel has the 7 wafer manufacturer or fabs worldwide. There's 4 of those in the US, 2 in EMEA and 1 in Asia. And then the 3 sites that are shown in green are our assembly tests. So that's basically the back-end packaging. So those 10 sites there represent our manufacturing. And in total, we have 57 million square feet worldwide of space. So that would include manufacturing space, data centers, labs, warehouses, plant rooms, office space. And of that 57 million, roughly about 50 million of that is Intel-owned space. The remainder is lease space. Okay, actually, I'll go this way. So, as Kevin had mentioned earlier, Intel kicked off its energy efficiency efforts probably back on a formalized basis back in 2000. And one of the reasons for a large focus on energy efficiency is that Intel values its reputation as a sustainability leader and views energy efficiency and energy conservation as one of the key pillars of our sustainability leadership position. So back in 2000, we kicked off the effort, and it was primarily with folks who were doing this on a part-time basis. And we continued in that fashion for a number of years because there was lots of opportunity there that needed to be addressed, right, and could be addressed at relatively low cost. Then in 2008, we moved to having a dedicated capital request. So we wanted to separate out energy efficiency, energy conservation from the typical ops capital requests. And we also put in place a central management of the program. So we had an individual whose full-time role was managing the program, even though they didn't have any direct reports. Okay. We continued to have some success, and in 2010 we formalized more in terms of how we track our efforts. So both in terms of ideas that we're coming up with that need investigation, projects that we've completed, projects that are in progress, and equally important, projects that we didn't proceed with and why they weren't proceeded with. Was it based on a technical hard barrier? Was it based on cost? What needs to change in the future that we could go back and revisit that opportunity? In 2011 is when I came on board to manage the program, and at that point we decided that we would put dedicated resources in place, and we had a mixed org structure at that time, and it was both direct and matrix reports. That was also the year that Kevin had mentioned Ireland got certified for ISO 50001. The folks in Asia then continued the learnings from the Ireland side with respect to 50001 and each of the sites got certified from our ATM from 2012 through this year. Actually, Malaysia is going to be certified this year. And one of the big changes we made in 2012 was we decided to ramp our efforts, and we increased the amount of capital funding that we direct towards energy conservation, energy efficiency on an annual basis. So over the last 4 years, we've committed 30 million a year just to drive energy efficiency and energy conservation in Intel operations. Now, obviously, all of those projects, right, are to support our sustainability leadership position, right? But equally important, they must add to the bottom line, right? So we're looking to reduce costs, we're looking to add to the bottom line. Now I'll go back to this slide. So in terms of our journey to driving energy efficiency, there has been speed bumps along the way, and probably typical of what everyone has seen in their own particular industries and companies. But when we look at a lot of these perceived barriers, they're actually really opportunities for us to drive energy efficiency. So, some examples would be, funding. Folks may have difficulty receiving funding for a project from another capital source, but if it can be positioned as energy savings and the primary driver is energy savings, then there's obviously a dedicated funding source there that they can avail of. We look to drive or leverage change control, which is very important in Intel, and we look to leverage that to drive proliferation of projects. Because once we've documented and once we've got the opportunity approved through the change control process, that allows us to rapidly proliferate that project across multiple sites. Also, one of the concerns from the system owners is, in some cases they view driving energy efficiency as taking a risk with their system, and typically we would look at energy efficiency as being complementary to quality and reliability. That actually driving in energy efficiency can actually improve the quality and reliability of your system. So in terms of what our overall strategy and philosophy is in terms of accelerating the energy efficiency at Intel is, first and foremost, we wanted to make the data visible. So we understood clearly where our consumption was real time, had a Pareto, we're monitoring real time the high intensity users and making that data visible to the owners and the system operators. I think there was a question earlier in terms of is there data available in terms of what would be considered good or excellent performance. We've leveraged, I guess, through informal contacts with our peers in the industry and also just using web searches, checking various industry standards. If there is data available, to use that as the benchmark in terms of where we want to be and looking to drive the best in class for our systems. We obviously want to drive energy efficiency into design, and we strive to do that, but one of the reasons for also looking to drive it into design is that if we do it as part of a major project as opposed to a standalone project, it's typically lower cost, right? So we don't have to remobilize the trades, We don't have to look for approval to take the system down. So it's easier for us to do it as part of a major project rather than doing it as a standalone project. In terms of capital approval, so we do have the $30 million a year committed to energy efficiency. All of those projects must meet a positive 5-year net present value, right? So that's our hurdle. It has to meet a positive 5-year NPV. Now, based on that, we look to take more of a portfolio approach to capital projects, so meaning that we know that there are some projects that have a much better return than that, but equally there are other projects that don't have as good a return. We want to balance that out for a given site, for a given system, so that we can address the overall efficiency of the system rather than just parts of the system. I guess one of the big things is we recognize that even though we have a lot of expertise within the group, and we've got pretty good diversity within the group in terms of expertise and experience. So we have mechanical engineers, we have electrical engineers, we have I&C engineers, we have water engineers. So we have pretty good diversity, a lot of expertise, a lot of experience, both internal and external of Intel. We're still looking to leverage the expertise of the suppliers and contractors in recognition of, there are new things that are being developed all the time, new technology, new ways of doing things, and we may not have visibility to those. And I guess we have an adage at Intel, let's not assume we're smarter than we really are, right? So we want to leverage that collective expertise that exists externally and use that to drive energy efficiency within Intel. And I guess the last thing is, even though we have an available capital source, we are looking at different models in terms of delivery of the projects. So we're looking at energy performance contracting and other approaches as well. Maybe energy performance projects, energy performance contracting, different means of delivering the project and identifying those opportunities. So I mentioned earlier that we view energy efficiency as one of the key pillars of our sustainability leadership position, but it dovetails in with our overall green energy global strategy. So we have set pretty aggressive goals, environmental goals, in terms of 2020 goals, and I'll cover those in a minute. We also are the largest voluntary purchaser of green power in the US. So our green power purchase in the US is equivalent on an annual basis to our total electric use in the US. And obviously we're looking at alternate energy sources as well, and have a number of installs in terms of solar hot water, PV, wind. And in total, over the last 7 years, since 2008, we have cumulative sustainable savings in terms of electricity of 2.4 billion kilowatt hours. Yeah. So in terms of our environmental goals, we committed externally to our corporate social responsibility report, and we published these in 2012, that we would save 4 billion, cumulative energy savings of 4 billion kilowatt hours between 2012 and 2020. And that ties in then with all of the other environmental goals. The importance to us to having a 2020 goal specifically on energy is that it just provides a rallying point for the organisation to drive and get that support to drive the energy savings and deliver those energy savings. And just in summary, since 2012, so in the last, say, 4 years, we've delivered over 2,300 energy efficiency projects worldwide. We've spent 120 million in capital. We have a corporate vice president who is the sponsor and the champion, and who we report out to on every other month in terms of our progress. We have definitely looked to shift from the once-off, one-time project at a given site to those projects that can be proliferated across multiple sites. Just making better use of our resources and increasing the velocity in terms of driving these savings. We'd mentioned that we're represented in 66 different countries. A number of those countries are leased spaces. and we are looking to see how we can address those as well. But based on the projects we've completed to date, we've completed them in 32 different sites across 17 countries. And just to Kevin's point earlier in terms of the 20% of the folks who influence the 80% of the energy use, we have about 300 individual project owners over that last 4 years, right? So 300 different individuals who originated and managed and delivered on a project. And that would roughly equate to about 12% of the folks in the org, right? And so obviously we're not quite at the 20%, but we're making traction getting there. Then the last slide is just the obligatory Intel slide. So that's it. Thanks, folks.
Thank you very much.